Welcome to Bungalows for Bachelors. Today we are going to learn about HVAC, also known as HVAC. So, what is HVAC? Well, remember, we are trying to create a space inside our houses that is wonderful and feels wonderful. And what I mean by that is we're trying to control the inside air in our house so that we're not feeling like we're outside. And that was the whole point, right? So HVAC is where we're going to worry about the heating, the ventilating, and air conditioning of that inside air. And the purpose, remember, is to establish and maintain the inside air environment at a pleasant level. That's the whole point. And that's what HVAC is going to be all about. It includes the heating portion, right? So am I going to have a gas furnace? I'm going to heat my, how am I going to heat my house in the wintertime, keep it warm when I don't want to be cold because the outside is cold? The ventilation. How do I maintain fresh air so I don't feel like I'm in a cave or something where I'd be like, stagnant, stale air, right? How do I got to maintain a lot of fresh oxygen? Because as humans and animals that we have in the house, we consume oxygen. So we got to make sure we're getting a fresh supply. So we can't just close off everything. That would be a bad thing. And of course, the air conditioning part, which is the opposite of heating. How do we cool the house on the inside when it's hot outside? So to talk about that, the first thing we're going to have to think about here is some basics of heat transfer. So the first thing to know is that there is no such thing as cold. There's only the absence of heat energy. Do you have more heat energy or do you have less heat energy? There is an absolute zero temperature, 0 degrees Kelvin, I do believe. And it's something like, oh man, I'd be testing my memory here, but something like negative 275 degrees Celsius or something in that range, right? It's very, very cold. That's where there is the theoretical complete absence of heat energy, which can only exist if there are no particles. I won't get too nerdy about it, but basically the premise is you can't introduce coldness. All you can do is try to remove heat from a place. And that matters when we're talking about air conditioning, right? So we can add heat to a house pretty easily. Either we have electrical resistance heating where we run a bunch of electricity through coils that are designed to get really hot, and that energy will be released into our house. And that's a very inefficient way of heating because you're going to consume more energy than in the electricity than energy you will gain from heat in the coils. So that's not very efficient. Burning gas is probably one of the more efficient ways to do it because most of the product gets burnt up and consumed and turned into heat. And of course, there's pumping heat into the house, which is known as air conditioning. This is pumping heat into the house. Air conditioning would be, you'd think of it as pumping heat out of the house, right? That's removing heat from the house. So how do you remove heat from a house? Well, we're going to talk a little bit about that and get into a little bit of drawing class here. So if I have, the first thing to think about is we're gonna talk about this in terms of central air conditioning, right? So what I'm gonna have is I have a house that's my contained box, and let's say it's hot outside. So if it's hot outside, we have a sun, and it's nice and toasty, and then somewhere over here in our yard we have a condensing unit, and somewhere up here in our attic we have our air conditioning unit. All right, so the basic premise is the air conditioning unit is going to accept heat. That was a bad arrow. It's going to accept heat from the inside of the house, and it's going to have these Freon lines, or not necessarily Freon, but R134A lines or whatever is used, refrigerant lines, and it's going to take those lines in a loop. It's designed to loop. On the outflow, it's going to carry that energy, and it's going to bring the energy down to the condenser unit outside. And that condenser unit has a big fan that's going to blow on a bunch more coils, and it's going to release that energy off into the outside. That's how that works. So you're taking heat from the inside and you're pumping it to the outside. And that's how you are cooling the air inside the house. So if we take a blow up of this basic premise here, let's take a look at the condenser unit that would be outside. So in our unit, we are generally going to have, we need two things. We need two flows of fluid in order to do heat transfer here. So I will draw the airflow. There's normally a fan blowing air up out of the air condenser, right? So air is getting sucked in. Well, it's really getting sucked in through the sides, but we're going to pretend it's getting sucked in through the bottom. So air is getting pulled in and pushed out with a big metal fan. That's normally you can look right in the top of your condenser and you see your metal fan, right? So that's one fluid is air. The other fluid is the Freon or the R134A, and we're going to draw that moving sideways through this thing, even though it's, not necessarily that simple. So it goes, basically what happens is the Freon, or I keep calling it that, but you call it whatever, refrigerant, I should just call it refrigerant, refrigerant, is going to contain that energy from the house, and it's going to flow through a bunch of little pipes. And those little pipes are going to have lots of aluminum fins on them. And those aluminum fins are going to be parallel with the direction of the airflow. So there's going to be a big fan that's going to blow all the air past those aluminum fins. And what that's going to do is it's going to pull that heat. Those aluminum fins are going to heat up because that excess energy from the house was pulled through with the refrigerant. So the air is going to go through here, pull that heat out of those coils. And then when the refrigerant that's leaving this is now going to be cooler, it lost some of that heat because the air sucked it out. So, and then it's going to go, back towards going back into the house, right, to pick up more heat from the house. So that's the basic condenser. And the evaporator, if you want to call it that, on the inside of the house that's up in your attic, its basic premise is the same thing. You're going to have some kind of central fan that is blowing air out of your ducts, wherever your ducts are. And there's going to be generally a central receiving air or a general input place where your most of your air is coming through. So on a typical house, you're going to have this big, it's where normally where your air filter is. The air is going to be pulled back into the fan. So you're going to get the same premise of some kind of register or grill where this air is going to flow through this filter. It's going to enter the fan and then it's going to blow out and it's going to go through the pipes. It's going to run through the pipes, right? And the pipes take the air to different places in your house and disperse the air. And that air just flows around through your house and eventually makes it back into this receiver, or what I keep calling it weird things. Keeps coming back into the grill, right? There's a technical term for it, I have no doubt. And that's just circulates through the house. So that's how that works, right? So there's airflow coming through this side, and then there are the evaporator coils, which are designed to do effectively the same thing as the condenser coils, but in the opposite way. So the refrigerant lines are going this way, right? So you got the same thing. You got a whole bunch of aluminum fins, a whole bunch of tubes of this fluid in contact with these aluminum fins, right? So the refrigerant, as it moves through these, it's going to pick up energy from the air temperature, from the air from the inside of the house, and it's going to bring that energy out of the house. It's gonna leave the house. Okay, so that's what's going on in those two. The second thing that's happening at the same time this is happening is these coils, in order for the air, so heat moves from hot to cold. So in order to get the heat to go from the air to the pipes and then into the refrigerant fluid, you need the refrigerant fluid to be colder than the air. So these pipes are cold. And what happens when the pipes are cold is anytime you run a warm air that has some humidity to it onto a cold surface, you get condensation. So while this is happening, all this air is actually condensing water onto the outside of these lines, which is why the inside of your house has to have a drain, because it's going to collect that water and it's going to run that water outside the house and dump it somewhere. So that's why you got to have that drain. And that is something that's continuously happening. And now what this is doing is, in the right proportions, it's dehumidifying your house. If you have a bunch of humid air, all that humidity is going to collect on these lines, and it's going to drip out of the house, right? So that's why the air that comes out of your vents when you're running AC is cool and dry, relatively comfortably dry. So those are multiple things that are going on here in the evaporator. So that's the basic function there. Now, in terms of, this is a central system, right? So the basic premise is there's one central fan that's moving the air around in the house, a bunch of ducts and a fan. The fan pushes air out the ducts, and then there may be return ducts or a return grill central somewhere that's receiving the air. Okay, but that's the basic way it works. Now there's ductless as well. And the way ductless works is the same premise of heat transfer, but let's see, use a house with 2 rooms, for example. I have a house with 2 rooms. This is a floor plan view. I got a ductless unit here and a ductless unit here. And I may have a tiny condenser over here, or a tiny condenser over here, or maybe I have one condenser that runs both of them. That's totally possible. But basically what's going to happen is that condenser is going to run those refrigerant lines in a loop up your walls in much smaller lines up to the box unit. I'm going to draw a profile view now. So this is like the wall, and there's this ductless unit up on the wall, and here's a person standing in the room, right? Happy person. So you get the idea what's going on. So up on the wall is this ductless unit, and outside is this little condenser. It's going to have lines that come in the wall. It goes up to here, and the return line is going to go back down and back out. So what's happening is the ductless units are designed to just mix the airflow that's already in the room, but do all the same processes. So instead of having one central fan that's moving all the air in the house, you have a bunch of individual units that are just cycling air in their one spot. So it's going to suck in air either from the top or from the bottom, and it's going to blow that air out into the room. So the process of the heat exchange is still happening inside this unit, but the air is only coming from the room and going back out into the room. You're not able to pull fresh air in the same way you would for a central system. And we'll talk about a little bit about what's going on about with that in the PowerPoint in the future. But for now, you need to understand that ductless units, this is what I'm referring to. They are ductless because there are no ducts. Okay. A central system has one fan, many ducts to flow that air out into the house. But a ductless system would have individual units in multiple rooms where it's just mixing the air in that room. Okay. So you'd rely on basically this and or natural ventilation of the house and or windows that can open and ventilate the house. Or maybe you have a fan that's just a ventilator that's central, but your heating and cooling isn't central. That's possible too. So that said, we'll go ahead and go back. So that is pumping heat. That is how that generally works. So like I said, the 2 types, central, where you're going to have ducts and registers, and ductless, where you're going to have units that mix the air. And they both do the same heat cool process. So central air, one of the benefits is that it usually is a lower initial cost because it is a somewhat simpler system. You only have one condenser, one evaporator, one fan. You're not multiplying these instruments all over. And the ductless units are kind of nice because they're usually kind of connected in a system. They're just kind of all over the house. So it's a little bit more expensive in that regard. But one of the nice things about essential air is that you can integrate air quality products. So I talked a little bit about when I have one central fan, well, that one central fan also has one big filter. So I can have one really nice filter that's like cleaning all of the air particle junk, depending on what level of filter you get. It's designed to work with your fan. And you can actually clean out, all the air and have very clean air, not just, nasty outside dusty air if you're next to a construction site or something, right? You can have very clean air inside your house being blown around versus a ductless where if you have a dusty room, it's going to have a filter in there, but it's ultimately just mixing the air that's in that room. It's not pulling that dust anywhere else, which is part of the reason you need to maintain ductless filters much more frequently than a central filter. But another positive of central air is it is much better for larger homes, because you can imagine if you have lots of rooms in a very complex large house, you're going to have a hard time putting these ductless units everywhere, and you're going to have a really hard time getting fresh air into places you really need it to go. And the best way to do that is to have the central unit that's pulling air from around the house and mixing it. And also the central units can have ventilation built in where it's going to suck in outside air and then blow out house waste air. So it's going to maintain a certain amount of fresh air coming into the house, which is good. So ductless are nice because they're more efficient in general. The actual heat transfer process is generally more efficient in this technology. So that will save a little bit on energy. And part of the other efficiency comes from the zone control, right? You can keep certain rooms hotter or colder depending on what you've programmed into your ductless units, and put the energy where you want it, basically. And of course, it is easier to hide the ducts and the lines. There are no ducts sometimes, but it's easier to hide all of the lines and HVAC running utility stuff, wires and whatnot in the walls. You don't usually have to have a space built into your framing to accommodate ducts. So that can be a plus. Now, in terms of building science, remember building science, the whole premise being improving the quality of what we're building, the environmental impact and the longevity of what we're building. HVAC is going to have one of the biggest impacts on this, because the whole premise on, having a tighter envelope with building science and having a good thermal barrier and, good walls with no thermal bridging and all these factors, right? They all play into maintaining the interior environment. And if you spend a bunch of money to improve your house and fix all these things in your building envelope and this, that, and the other, but you buy the cheapest, crappiest HVAC system, well, you're probably going to get a cheapy, crappy end result of an interior environment, even though the rest of your building may be efficient. So that's why HVAC has one of the biggest impacts, is because it's where you're going to introduce your ventilation, right? You're going to have fresh air coming in just the right amount. And with that ventilation, of course, you think about, all right, let's say it's really cold outside and I'm heating my house. And, well, let's flip it around. Let's say it's hot outside, very hot and humid. We're in Texas, right? And it's cool inside. And I'm going to ventilate, which means I'm going to pull fresh air in, which means I'm going to pull hot, humid air in, mix it with my cold air, and then release into the house, right? So I'm getting fresh air, but it's dirty and it's, hot and it's got moisture in it. So I want to avoid those things if I can. And that's where an HRV or an ERV comes into play. So a heat recovery ventilator is a device that's designed to go with your ventilation system that exchanges the heat energy between the incoming and outgoing air. So it's like a little heat transfer device that crosses streams that are not, like, it's not actually mixing the streams, but it crosses the streams in terms of their flow and allows them to transfer the heat energy between one to the other. So what happens is, if it's air conditioned inside your house, you've got cold air blowing out of your house and you've got hot air coming into your house where they're going to cross those streams. And the heat that's coming in is going to get pushed into the cold air that's going out. And that, of course, is going to reduce the temperature of the air coming into your house. So you're going to retain some of that energy that you've tried to, you spend a bunch of money pumping that heat energy out of the house. You're going to retain some of that with the ventilation system. So, and it's much more efficient. You end up keeping a lot of the energy. Now, the ERV is an energy recovery ventilator or an enthalpy recovery ventilator. You can think of it that way. This is basically the same thing as a heat recovery ventilator, but it is also going to it's also going to allow you to recover the moisture quality, right? So if I have hot, humid air coming inside and I only have an ERV, then for the most part, I'm only going to be switching that incoming air to cold, humid air. Well, I still have the humidity. And I don't want the humidity. I want cool, dry air. That's what's the most comfortable. So, an ERV is going to allow the moisture to be pulled out of that air in addition to the temperature being dropped. So that's basically what happens. It pulls the moisture out of the incoming air and it blows it out into the outgoing air. So that's pretty cool. Of course, you can have dehumidifiers built into a central system. And the basic premise there is when you have a dehumidifier, you have exact control over the humidity and the amount of moisture content in your air in your house. When you don't have a dehumidifier, you are relying on your evaporator coils to dehumidify your air. Remember in that drawing, I showed you that when the cool house air is running past the coils, it's condensing on those coils and removing moisture out of the air. That's dehumidifying the house. But that only works while your air conditioner is running. As soon as your air conditioner stops running because you have a good temperature, then it's not dehumidifying your house anymore. So it's possible that you can maintain a good temperature, and if your fan's not running too often, you're going to get maybe a more humid environment. But if you have a dehumidifier, you can run that dehumidifier without running your air conditioning pump and cooling the air. You can dehumidify it without cooling it necessarily. So that's nice. And of course, filtration. When you have a nice big thick filter on your central air system, you can clean out the air and make very particle-free air come through your house, which is really good if anybody's got allergies or things like that. It's going to remove all those particles. So that's always great. And if you'd like to learn more, you can watch the YouTube Spec House series, episodes 42, 98, and 131 by The Essential Craftsman. You should watch the YouTube video HVAC Done Right, Watch This Before You Install by Matt Reisinger, and watch the YouTube video Central Air HVAC System versus Ductless Mini Splits, Pros and Cons by Fire and Ice Heating and Air Conditioning Incorporated. Thank you for watching. We'll see you on the next video.